So Rocky, take it away.
Okay, thank you, Jessica. Hello, everyone. I'm Rakhi, working as grad stats tutor for USP. Welcome to the seminar. Today we are discussing SPSS. So for today's seminar, we are going to talk about how to install SPSS, what is SPSS, some basic syntax like importing data, handling missing values, computing variables, manipulating cases, and then we'll do some descriptive analysis. Then we'll do some relationship analysis, types of t-test, ANOVA test. So how to perform these tests on SPSS. Later, we'll do some regression analysis, how to perform linear regression. And towards the end, we'll give a brief introduction about our graduate academic support center, procedure to book appointments, and so on. So let's start with the software SPSS. SPSS basically means Statistical Package for Social Sciences. So that's SPSS. It was first launched in 1968. It was later acquired by IBM in 2009. And since then, we call it IBM SPSS. It is basically a tool which helps you do all sort of analysis, statistical analysis. You can create tables, graphs, and SPSS is capable of handling a large amount of data and can perform hypothesis testing, and it is basically used by customers, scientific researchers, and even business people use SPSS. One of the main point of SPSS is it supports all file format. So you can have your data as spreadsheet or Excel file, normal CSV file, SQL, SQL, Stata, SAS, anything, and you can import data directly into SPSS. So, but we have a lot of softwares available for statistical analysis. We have R, Intellectus, Excel, Microsoft Excel, and then SPSS. So why SPSS? So first of all, it is very easy to use. The interface is very user-friendly, and you just have to follow certain steps, and then you can do all sort of analysis. As I said before, it works across multiple data sources. Then it is a very powerful tool which gives you very meaningful insights from your data, and it is used for businesses and research problems as well. So overall, SPSS is easy to use, can be learned very easily, and helps you perform all of the statistical analysis you can think of. So that's SPSS. It is a licensed software. So although you cannot get it for free, it comes with monthly subscription offers, but ASU provides all the students and faculty SPSS for free. So as a ASU student or as part of faculty, you can use SPSS for free. You can go to this link, or you can go to my ASU, my apps, and search SPSS, and you can download it from there. So once you click on this link, you'll be forwarded to this page, and here SPSS gives you an option to run SPSS virtually. Like, you don't even have to install SPSS in your local machine. You can directly use SPSS virtually. You just have to click on Run App, and there you go. You can have SPSS running on your system. But if you want to set up SPSS locally in your local system, then you can select the SPSS version you want. So SPSS keeps on updating their softwares. So like 28, SPSS 27. So depending upon the version you want and the OS you are using, like Mac OS or Windows, Linux, you can just click on the corresponding link, and you can just download it. Once you download the software, you just have to install it. So for installing, you just have to open the downloaded file, do some next, agree to the agreement, and then you have SPSS installed on your system. So you can take the benefit of being part of ASU and use it for free. Once you have downloaded the SPSS, installed it on your system, you can simply open it by double-clicking on the icon, SPSS icon. And once you open it, you will have a data editor window in front of you. It will have two views. Okay, I'll just show you. So the moment you open SPSS, you'll have this view in front of you. So you have two options. One is the data view and one is the variable view. So the current screen is the data view. What data view shows is the data which you have imported in your SPSS. So it will show you the variable names, like the data which is just now shown is consists of 3 variables or 3 columns: ID, name, and score. And it has 4 entries or 4 rows. So you see, you have 4 rows in your data set, the data values, and you have ID, name, and score. So this is how the data view looks. If you go to the variable view, you just have to click on this button and you can jump to variable view. For the variable view, so this is your variable view. So variable view basically shows all the variables you have in your data set, their type, their width, and their, most importantly, level of measurement. So in the variable view, you'll have the variable name, their type, so they can be string, numeric, and the level of measurement. Level of measurement can be of 3 types. We'll discuss this further. So like for the ID, it could be string. So that's string type, string as in it can contain alphanumeric characters like A, B, C, D, plus the numbers as well. So that's string for you. Then the width. So what width means is number of characters it will have. So like for ID, they have fixed it, like they'll have 5 characters in their ID. Then if you know the ID will have some missing values, you can mention it right here in the missing value. And the measure. Same for name. Name is also a string, but for score, it's a numeric value. So you said, because you know score will only contain integer values, the numbers like 28, 88. So it is numeric. So this is the variable view. Now let's discuss the level of measurement. So SPSS uses 3 different measurement levels. First one is ordinal, then nominal, and the last one is scale. So nominal is basically for categorical data. Ordinal is like when your variable follows certain order, and scale is like the numeric data we have. So let's see some examples. So this is the 3 level of measurements: scale, ordinal, and nominal. So for nominal variable is a variable whose values don't have an undisputable order. So when I say undisputable order, I mean they don't have any certain order to follow. So like, let's say we asked people in which country they live. So they might give you answers like United States, Canada, Mexico. So you cannot order those countries. Like they don't have any particular order to follow. So therefore country is a nominal variable. Again, suppose you ask people their gender. So all the answers they give, they don't have any particular order. So gender again comes under nominal. So all the categorical variables usually comes under nominal. Then we have ordinal. What ordinal means? Although they'll have an undisputable order, like they'll have some order assigned, but no unit of measurement. So like for a question like, how did you like your food? So people can answer bad, neutral, good. So obviously there is certain order, like, good is like at the top, then we have neutral and then bad, but they don't have any specific unit like dollars or seconds. So there is no unit attached. You cannot do any mathematical or any calculation on ordinal variables, but they do have certain order with them. So that's ordinal. And the last one is scale. So the interval or the ratio variables, the mathematical variables come under scale variable. So like number of purchases done, or cholesterol level, or age, or height, or weight. All these are example of scale level of measurement. So like the previous example, uh, the score for a student also comes under scale. So that's a 3 level of measurement. It's important to know which variable will come under which level of measurement, because depending upon the type of variable, we have different tests to perform. So these are the level of measurements. Next, if you look at the SPSS window, you'll find this menu bar at the top. The 5 important menu bars are file. So because you can open a data set, save a data set, you can open an output file, import or export the data set or output file under the file option. For data, you can it supports all kind of restructuring process. So like if you want to define properties of the data set or split cases, sort them, so you can do all sort of data related operation under the data menu. Then we have transform. So transform basically supports manipulation of data. If you want to transform your data into something else, so suppose you want to add a new variable, you want to replace the missing values, so all these things come under transform. Then we have analyze. So this is the most important option. So for all the test, all the analysis you want to perform, that all comes under analyze option. So that's an important option. You'll keep on going to that option. And the last one is the important one is graph. So graph will help you to visualize the data. So you can create all sort of charts and plots using the graph option. So these are the 5 most important menu options you'll use. Now let's go ahead and discuss the basic syntax involved in SPSS. So the most important one, the first step you would do is import the data set. So you can simply go to file and click on import data. And once you click on this, import data, you can select the type of data you want to import. So it could be Excel file, CSV file, or from a different software, SAS file. So you select the data you want to import. So suppose you want to import flight fare. So you just click on that and you click on open. Now, for Excel file, they'll give you an option. Do you want to open which sheet number? So Excel file has different sheets. So you can select the sheet you want to select. So it's sheet 1. You can even select a range of data. So if it's a big Excel file with lots of rows and columns, so you can select a range like you want to. If it's a big Excel file with lots of rows and columns, you can select a particular set of rows and columns to import. So you can enter it under range. And there are several other options like reading the variable name from the first row of the data and all those things. And simply you can click on OK. Once you click on OK, the data will be imported into SPSS and you can start analyzing the data. Once you have imported the data set, there could be a chance that you want to insert a new row in the data. So suppose you have all these data sets, data under your data set, and you want to insert a new row. So you can do that. You can directly go to the data view. The data view we just discussed. Right click on this row, the place you want to insert, and just select insert cases. So right click on a row and select insert cases. Or else you can even go to edit at the menu bar and select insert cases. So by doing this, you can insert a new row to your data. So once you do that, you can manually enter the data in your data set. Similarly, if you want to delete a single row, you can just go to the data view and select the row you want to delete, right click it and select clear. So in the data view tab, you click the case number, row number you want to delete. Suppose you want to delete the third row, you just go to the third row, right click and select clear. So, or you can just simply press the delete key on your keyboard and it will delete this the row for you. So you can insert data, delete data in SPSS. Now next is computing a variable. So suppose in your data you have cost one, which means cost for the first month, and you have another variable cost two, which is the cost for second month. But you don't have the total cost column in your data set. And you want a total cost column in your data set, which means cost one plus cost two. So you can compute a new variable in SPSS. So you go to transform, go to compute variable. These are transform is present in the menu bar at the top. So you go to transform, then you go to compute variable. Now you select output the variable name. So you select the variable name you want. So I said total cost. So you can just type total cost here, and you can enter the numeric expression you want. So for our example, it would have been cost one plus cost two. You can just type this cost one plus cost two, and you can just click on OK. So it will create a new variable in your data set with a new variable named total cost, which would be the summation of cost one and cost two. You can do a lot of math function, not just summation. You could do conversion, differences, product, all those things. So this is computing a variable. Next is recoding variables. So suppose you want to recode your variable. So when I say recode, suppose you asked people to rate their classes. So people could rate from 0 to 100. So they are giving ratings to the class they just attended. So some people can give a rating of 0, some 55, some 100, anything. And now you want to recode them. So you want to put a range. So suppose you want to say all the values between 0 to 20 should be recoded as bad. All the values from 21 to 50 maybe is average. And anything above 50, greater than 50, 50 to 100, you want it to be good. So you want to recode your variable like this. So you don't have to do it manually. SPSS can do it for you. So you just select the variable you want it to be recoded. So you suppose you select score. You select this arrow, click this arrow, and now you click OK, and then you put in the range, like you put in the old values, or you put in the new value. So suppose he gave in this example, we gave the range 51 to 70. Okay, so for 51 to 70, you put the new value as very good. So all the values between 51 to 70 would change to very good in your data. So you can do this through SPSS. This is under transform. Again, transforming a variable, recode into different variables. So this is the way you can recode your variables. Now, how to handle missing values. So suppose you have a data set and it has some missing values. So there are two types of missing values. There are some system missing values and user missing value. So suppose a user, so this is a data set. This is the position. So like this is the graduate statistics tutor, graduate writing tutor, so on. And somebody entered NA, not applicable. So this is user missing value. And if somebody did not enter anything, like it's empty, so that's system missing value, SPSS would mark it as a dash, hyphen. So you can even handle these missing values. You can replace them by any value you want. So to handle the missing values, replacing the missing values, you go to transform, you go to replace missing values, you select the variable you want to replace, and now you have a lot of options. You can replace it by the mean of the variables, or you can just replace it with a 0. You can replace it with -1. Like depending upon the application, you can replace the missing values of any data set. So that's replacing missing values. Then Okay, sorry. Yeah. So this is split file. Suppose you want to split your file based on groups. So suppose in your data set, you had an option as gender with 2 values, female and male, and you want to split it. So you can just go to data, split file, select the gender group, and click on OK. So all of your data set will be divided into 2 parts. One would represent the female gender, one would represent the male gender. So you don't have to again do it manually. SPSS would help you do it. So that's splitting the file. Now, next is data visualization. So this is the part I was talking about, the graph part. You can create a lot of plots to visualize your data. You can create histogram, scatter plot, line graph, area, bar plot, pie chart, box plot. So you simply go to graph chart builder. So this dialog box will appear. You click the variables you want to include. You select the type of chart or graph you want to select, and click on OK. Depending upon the graph you selected, you'll get a different different box to select from, like to name the axis, to rename the axis, maybe, and like depending upon the graph, you'll have different menus. So this is about data visualization. I'll not go into much detail about this. So moving on, we can do descriptive analysis now. So that is just the basic statistical analysis which we do with the continuous variables, continuous scale, like finding the mean, standard deviation, getting frequency. So there are 2 types of statistics that are used to describe data. One is measure of central tendency, which involves mean, median, mode. And then the second one is measure of spread. So the spreadness involves standard deviation, variance, range, quartiles. So like these are the basic descriptive analysis which we do. So you can do these things very easily in SPSS. Under SPSS descriptive analysis, you can do like the central tendency, spread, percentile, skewness, kurtosis, histograms, frequency distributions, all those options. So, okay. So like suppose you want to do frequencies. So you just go to analyze, you go to descriptive statistics, and you select frequencies. So once you go to click on frequencies, it will ask you the variables you want to select. So you select the variables for which you want to calculate the frequencies. You select ID, name, position, scores. Then for under statistics, if you click on this statistics option, it will ask you to select all the type of different descriptive statistics you want to do, like mean, median, mode, and then you can click on OK. So like the basic difference between descriptive and inferential analysis is descriptive measures the central tendency and dispersion, but inferential analysis helps you make inferences about the data. So under inferential analysis, we do the hypothesis testing. So you should always do descriptive or qualitative analysis before you do inferential statistics. Like before doing the hypothesis testing, the first step should always be to do the descriptive, get to know the data well, like knowing the mean, median, mode, standard deviation, the distribution, and then you should go ahead with inferential analysis. One of the most common descriptive statistics we can do is normality test. So like a lot of statistical tests like t-test, ANOVA requires that the data you are using should be of normal distribution, like it should follow this bell curve distribution. So to test whether your data follows this assumption, like the normality assumption or not, you can simply go to analyze. So again, going to analyze, descriptive, explore, and then you go for you select the variable you want it to be tested for normality. So like suppose you select scores, then you click on OK, then you click on continue, and you get this output table. So an output table will open up and you'll have this output for the normality test. So you have two different types of normality test. One is um, Kolmogorov-Smirnov, and the next one is Shapiro-Wilk. So Shapiro-Wilk is used when your data set is smaller than 2000 elements. So if your data set is smaller than 2000 elements, we go with Shapiro-Wilk, and for like otherwise we go with this one. So you have this table, you look at the significant value. So look at the significant value. If it's greater than 0.05, so if the value is greater than 0.05, you say that the variable is distributed normally. So in our case, it's not, it's greater than 0.05. So we can say that the score variable is normally distributed, and then we can go ahead with different t-tests and over tests we can perform. So this is about normality test. Next is relationship analysis. So we can find the relation between two variables, like how two variables are related to each other. So suppose you have two variables as height and weight, and you want to know whether by increasing the height, where the weight increases or decreases. So to know the relationship between two variables, that is correlation analysis, we do the correlation analysis basically. So like for continuous variables, we have Pearson correlation. For ordinal variable, we have Spearman. And for categorical, we have Kendall's tau. So depending upon the type of variable you have selected to compare, you can have different measures to do that. So again, it's you go so you go to analyze, you go to correlate, and you select bivariate. Since you're comparing two variables, so you select bivariate. So analyze, correlate, and then bivariate. And once you select that, you select the correlation coefficient you want to do. So again, as we discussed, for different types of variable, you'll have different correlation coefficient, Pearson, Spearman, or Kendall's tau. And you select the two variables you want to compare. Suppose we want to compare scores and work hours. So you select them, you select the type of correlation coefficient, and you click on OK. So this is the output you will get. This is the output you will get. So you look at first of all, this score, like the work hour score, like the square and work hours. So this score, so it's a positive score. It is 0.785. So it's a positive score. That means they are positively related. So that means like scores and work hours are positively related. So if you increase score, work hour will increase. If you decrease score, work hour will decrease. So that's positive correlation. And then you look at significant value. So how significant the result is. So if it's less than 0.05, you say that, okay, if it's less than 0.05, you say that, okay, the significant correlation exists. Like this is a significant result. So you look at both the values, you look at the correlation value and even the significant value, whether that correlation value is significant or not. So that's correlation analysis for you. Now let's jump to some tests which we can perform. So let's start with a simple t-test. So this is one sample t-test. This is used to compare the mean of a population and a sample. So you have a population, let's say you have age of entire US, and then that's the population for you, and then you have Arizona as sample. And so this is, so if you want to compare whether the average age of Arizona people is similar to the population or not. So you can do this by one sample t-test. So to do that, you go to select, you go to analyze. So you go to analyze, then compare means, and then you select one sample t-test. So once you do that, you can select the variable you want to perform. Like the example I gave, you could have selected age, and you could give the average age of the population. So like you could have given average age as maybe 45 or anything in the test value. So that's the population average. This is the variable you want to test, and then you click on OK. So this is the result of one sample t-test which you'll get. So you'll get the t-value and you'll get the significant score. So if you check if the significant score, the p-value, this is the p-value or significance. If that's greater than 0.05, we say that we fail to reject our null hypothesis, as in there was no significant difference, as in the population of US and Arizona have no significant difference between them. So that's one sample t-test. So once you know which test to perform, it's very easy to do that in SPSS. Next test we have is independent sample t-test. So suppose you want to compare mean between dependent variables that belong to two independent groups. So let's say you want to compare the score of a test between between different genders. So suppose you have male, female, and you want to compare which group performs better. Or between, suppose you have a medicine, you have a new medicine, and you want to compare between control group and treatment group, which medicine, like which group has better effect of that medicine. So for comparing two different groups upon a single dependent variable, we use independent sample t-test. Now the groups could have equal variance or unequal variance. So you can perform that independent sample t-test for both the groups, both the types of group, and it can be easily done in SPSS. So now how to perform independent sample t-test? Again, you select analyze, you go to compare means, and now this time you select independent sample t-test. So it's all under the compare means. So you have one sample t-test, now you have independent sample t-test. So you select an independent sample t-test. Then you select the testing variable, like I said, scores. So you selected score. Then you select the grouping variable, like the groups you want to form. So under gender, we had two groups, male and female. This will come under grouping variable. The score will be under testing variable, and you click on OK. So once you click on OK, an output table would be generated, which will show you if the equal variances are assumed, if they are not assumed. For both the cases, that show you the result. So you again look at, this is the t-value. Then this is the significant score. So if significance is greater than 0.05, you say that both the groups have no significant difference. So that means male and female groups both have no significant difference between their scores. So this is how you do independent sample t-test. Then the next test we can perform is paired sample t-test. So for paired sample t-test, when we have this, is used to determine whether the mean of a dependent variable is the same in two related groups. So suppose two groups of participants that are measured at two different time points or who undergo two different conditions. So suppose a group of students, a group of 10 students were asked to give a test. So they gave an exam, they had a test, so that, let's say that's pre-test score. Once they gave this exam, they were trained, they were asked to go under a training, and after the training, the same set of students were asked to appear for that exam again. So the same set of 10 students appeared for that test again. So that would be post-test score. So now we want to compare whether there is a significant difference between the pre-test score and the post-test score. So there's a single group which has given the test twice, one before the training and one after the training. So when we have the same group having two different scores, we go for paired sample t-test. So for paired sample t-test, again, we'll go to analyze, we'll go to compare means, and then we go to paired sample t-test. Once you select that, you'll have to select the variables. So you select the pre variable, the score pre. You select the score pre and score post. So this is score pre and this is score post. So these are the two variables which we want to test. Like, let us compare the scores of the tutors before and after the training. So this is the pre and post scores. And then you click on OK, and this is the output you'll get. So this is the t value, and this is the significance value. So if the significance is greater than 0.05, we fail to reject the null hypothesis, which means there is no significant difference in scores before training and after training. That means the pre and the post score has no significant difference. Like, the training did not change much in the score. So this is how you do different t-tests. Now a different test is chi-square test. It is used to discover if there is a relationship between two categorical variables. So suppose you have two different categorical variables and you want to see if there's a relationship between them. So it is also known as a test for association. You use chi-square test to check if there is an association between the selected categorical variable, like there is some relation between those two variables. So this is under cross tab. So you go to Analyze Descriptive Statistics, cross tab. Once you select that, you will select the variables you want to compare. So there you selected position and gender. You want to see, is there any relationship between the two variables, position and gender? Both are categorical, right? So you select both the variables, you select the chi-square, and you click on continue. Once you click on continue, you'll have this table, chi-square test, and this is the value you look for, the significance values, the significant value. So if it's greater than 0.05, you say there is no association between the variable. And if the value is less than or equal to 0.05, you say there is an association. So these are the simple tests you can perform to find whether the two categorical variables have some association between them. After chi-square test, we can go for ANOVA test. So ANOVA is similar to t-test, except in t-test, we have just two different groups. In ANOVA, we can have two or more than two groups. So first type is one-way ANOVA. So it is used to compare means between more than two independent groups. So you have more than two independent groups, you go for ANOVA. So let's compare the time taken by the staff who were trained on different courses to solve a problem. So like the courses were for beginner, intermediate, and advanced. So the courses had three groups: beginner, intermediate, and advanced. So you had three different groups, so you'll go with ANOVA. So you go to Analyze, Compare Means, and One-Way ANOVA. Once you select that, you will select the dependent variable, like you wanted to see the time taken. So that will go under dependent variable, time. And the factor is like the group you want to test upon. So the factor course, like it has three: beginner, intermediate, and advanced. So that will go under factor. So the post hoc is for pairwise comparison. So suppose you want to compare between separately compare between beginner and intermediate. You want to compare between intermediate and advanced and beginner. So if you want to do pairwise comparison, you can go for post hoc as well. So, but this is the basic one-way ANOVA, and then you click on OK. So once you click on OK, you'll get this output table. So if the significance is less than 0.05, which means we can reject the null hypothesis, and we can conclude that there is a difference in time taken to solve a problem between staff who take different courses. So since our value is 0.021, it's less than 0.05. So we can say that the three different groups, beginner, intermediate, and advanced, has a difference in time taken to solve a problem. So this is how you do one-way ANOVA. And since we selected the post hoc option as well, so you'll get, if you select the post hoc option, like to do the pairwise comparison, So this is different post-hoc methods. The most common one is the Turkey method. So you can select that, you can put in the significant value, and then you can click on continue. So this is the output you'll get to compare the pairwise comparison, like beginner with intermediate, beginner with advanced, intermediate with beginner, intermediate with advanced, and so on. And again, you can look at the significant value and you can accept or reject the null hypothesis. Like if there is relationship between beginner and intermediate. So that's how you can do the pairwise comparison as well. So this is all about one-way ANOVA. Next. Next is the regression analysis. So we have linear regression. So it is used to predict the value of a variable based on other variable. So suppose let's take the example of height and weight again. So we have height, we have weight, and we want to find the value of weight based on height. So if we know the height of a person, we want to predict the weight of a person. Or suppose if we know the area of a house, we want to predict the cost of the house. So let's say it's area and cost. So for examples like this, we can go for linear regression. It is used to predict the value of a variable based on other variables. So to do something like that, this is you go to analyze, you go to regression, and you click on linear, since we are doing a linear regression. Then you put in, like, we have income and price. So you put income in independent and price as dependent. So you want to predict price based on income. Let's try to predict the price of a car an individual would buy based on their income. So based on income, we want to predict the price of a car a person can buy. So you select those two variables, and then you get this table, this result. So this is the constant value which we get, and this is the income coefficient. So this is like something like this. So you based on income, you wanted to predict the cost of the car, and this is the linear regression. So you'll get the equation of this line. So it's like constant. This is the constant value. This is cost, and this is the slope of this line, that 0.564. And you can again see if the result is significant or not, looking at the significant value. So this is linear regression. And so these are the basic tests which you can perform on SPSS. So we covered starting from like managing the data, replacing missing values. Then we moved on to different type of tests. So we did t-test, ANOVA test, chi-square test, normality test, and then we did correlation, and this is linear regression. So I think that's all for today. I'll ask Jessica to jump in and tell you about our academic support center.
Yeah, thank you for that, Rocky. If you wouldn't mind going to the next slide. Yep, so we have two different options that students can access within graduate tutoring. So all of these are one-on-one appointments, and our two options are graduate writing tutoring. So if you are working on a dissertation, thesis, some kind of master's course that involves papers, you can meet with a tutor and they can discuss the feedback and give you feedback at any stage of the writing process, all the way from kind of ideas to annotations. And then we also have graduate statistics tutoring. So especially if maybe this went a little fast, if you have additional questions as you're getting into SPSS, I would highly recommend graduate statistics tutoring. So you can meet with a tutor to discuss, again, applied projects, research projects, or research classes. All of this tutoring is offered solely online, and all of it is one-on-one with a peer tutor. So similar to Rocky, we have a great team of grad stats tutors and also grad writing tutors. All appointments are an hour long. Our hours are below Jackie, I'll have you go to next slide. And then we also have some other options as well. So in addition to just tutoring, we have these online graduate workshops. We have wrapped up all of them for our statistics arm. So anything on statistics has already happened. This was the last one. But if you're looking for, we have intro to R and then also statistical concepts. Those are on the website. You can watch those as recordings. And then we have some additional writing topics throughout the semester. So similar format. If you need help on papers and that kind of thing, I would definitely check out those workshops. And you can also double back and watch any of ours as a recording. And then we also have graduate writing camps. So those happen over the summer and kind of two different options. One is for anyone working on a dissertation, and then the other is for kind of more general, again, master's papers, theses, something like that. Those are our only things that cost money. And they give you kind of dedicated support and dedicated feedback time to work on whatever you're working towards in graduate school. And then we also have resources if you are starting writing and you want writing group support. We can match you with similar people in your program or people that are working on something similar in different programs and give you the tools to get feedback from one another. All of our information is available at tutoring.asu.edu/graduate. That's kind of the best place to start. You can book a statistics tutoring appointment, writing appointment, or get any info about what we offer through university academic success programs. And then lastly, the ways to contact us, best way is going to be on that website. That's a great starting point. You can also call us if you have any questions or if you need help scheduling an appointment. I would recommend to definitely schedule appointments further in advance if you need tutoring or stats tutoring or writing help. Those appointments do fill up fast. So I would definitely recommend going online now if you haven't done so already and schedule an appointment. Again, they're free. They're private essentially because they're one-on-one. So it's a really great resource that ASU has for all of you. With that, I will turn it over to questions. I will just remind you guys that I'll go ahead and stop the recording